Welcome to Lesson 03 of System Mastery, the one where typebox finally stops being a guess. This single directive is the most misunderstood in all of System, and the wrong value is why services exit instantly, loop on restart, or just sit there marked failed. The fix isn't trial and error, it's understanding what each type tells System to expect. 5 types, 5 life cycles, 1 decision tree. After this lesson, you never guess type talkers again. So think of type towers as a contract, a 4-clause contract between your binary and systemd. Clause 1. When is the service actually started? Clause 2. What does it mean when the binary exits? Clause 3. Which PID should system track? And Clause 4. When do dependent services get the green light? Get any one of these wrong and you get the failure mode in the box. After, deps firing too early, confused, active versus failed state, restart and stop quietly doing nothing, or full-blown race conditions cascading through your stack. And here are the 5 contracts laid out side by side. Watch the star. That's the exact moment system flips the service to started. For simple, it's the instant exec fires. For forking, it's when the parent exits. For notify, it's the ready 1 message your binary sends. For oneshot, it's a clean exit 0. And for dbus, it's the moment your bus name appears on the bus. Same star, 5 completely different triggers. And that's the whole game. Let's start with the simplest contract. Type T simple. If you leave type out entirely, this is what you get. The deal is straightforward. System execs your binary, and that process must stay in the foreground. No forking, no demonizing. The PID system launches is the PID it tracks, and the moment that process exits, the service is considered stopped. 2 traps bite newcomers here. Pointing simple at a binary that actually forks and assuming after waits for readiness. It doesn't. For that, you'll need notify, which we'll get to. Typo forking is the opposite contract, built for the old guard, Apache, classic Nginx, postfix. The binary forks a child, the parent exits, and system treats that exit as the started signal. But to track the surviving daemon, it needs a PID file, and this is where things get fragile. Forget the PID file and system loses the child. Get the path wrong and stop hangs forever. Let the file appear after the parent exits, and you've got a race. It works, but it's why modern daemons just stay in the foreground and let system handle the backgrounding. Type notify fixes that race entirely. The binary itself tells system when it's truly ready, sockets bound, cache is warm, accepting connections, by calling SD notify with ready 1. Until that signal arrives, anything chained with after simply waits. That's why Nginx, Postgres, and OpenVPN all ship with it today. And the bonus, pair it with watchdogsec, and your binary has to keep pinging or systemed restarts it. The rule is simple. If you control the code, prefer notify always. That covers the 2 heavy hitters. The remaining 3 each solve exactly 1 problem. Oneshot is for tasks that run and exit. Setup scripts, migrations, firewall rules at boot, and pairing it with remain after exit keeps the unit logically active afterward. Dbus is for services that publish a name on the bus. System waits for that name to appear before declaring you started. And idle is purely cosmetic. It delays startup so your output doesn't shred the boot log. Niche, but when you need them, nothing else fits. Now step back and ask why type sockets matters at all. It's the contract your service signs with system about when started actually means ready. If db.service uses type sock simple, started just means exec returned. Your web app races in, hits a closed socket, and crashes. Type notify fixes that with 5 lines of SD notify, and every dependent service downstream finally gets honest signals. Pick the wrong type ratio, and system will happily report active on a service that's already dead. So here's the cheat sheet. 5 questions, walk top to bottom. Does the binary exit after its work? Oneshot. Does it fork itself? Forking. Does it call SD notify? Notify. Does it claim a dbus name? dbus. None of the above, stays in the foreground? Simple. That's it. Print it, tape it to your monitor, and after 3 or 4 units, you won't need it anymore. When in doubt, start with simple. It's the easiest thing to change later. Theory's only half the job. Now you build the instinct. 3 drills, 15 to 30 minutes each. First, audit your own machine. List 5 real services and figure out why each one picked the type it did. Second, write a tiny notify daemon yourself and watch system actually wait for your ready signal. Third, take a forking service and migrate it to simple, usually 2 lines of config and suddenly no more PID file races. Do all 3, and the decision tree stops being a chart on a slide. It just becomes how you think. Before you head off to practice, here are the 5 type tog mistakes you'll almost certainly make first. Type tog simple on a forking binary. Service looks active, isn't. Type tog forking without PID file. System loses the daemon entirely. Type notify on a binary that never calls SD notify, hangs 90 seconds, then fails. Type oneshot without remain after exit, shows dead after success. And type doc simple where notify would work means dependence race a not yet ready service. Memorize the fix column. That's your debugging shortcut. That's lesson 03 in the bag. 5 types, 5 life cycles, 1 decision tree, and the contract between your binary and system should now feel obvious rather than mysterious. Next up, lesson 04, targets, run levels reborn, multi-user, graphical, rescue, and how to switch boot states deliberately instead of hoping. That closes out the foundation stage, and from there we move into operations. See you in the next one.